Hi, and welcome to the Engineered Mind podcast, a podcast about engineering, AI, neuroscience, and other interesting topics of life to educate and inspire people all around the world. I'm your host, Jousef, and for this podcast, I welcome Dr. Krishnendu Chaudhury. He is one of the world's foremost computer vision and deep learning experts. Over his 20-year career, he's been directly responsible for some of the most groundbreaking technical innovations in the history of Google, Flipkart, and Adobe. Today, he's charting and realizing a technical vision for digitizing human actions in real time. A challenge that's pushing the boundaries of computer vision and deep learning even further. He's also the author of the book Mathematics and Architectures of Deep Learning. And now, ladies and gentlemen, here's my conversation with Krishnendu Chaudhury. Krish, it's a pleasure to have you on my podcast. It's really an honor. You have such an amazing amount of experience that you have gathered over the years. And to get started, maybe you introduce yourself to the audience a bit, what you did, because you did so much. Maybe you can explain what you're working on.
Thanks, Jousef. Yeah, so hi, everyone. My full name is Krishnendu Chaudhury, but a lot of people call me Krish. Jousef insisted that he wants to call me Krishnendu, which is great. Anyway, so I am at present CTO and co-founder of a company called Drishti Technologies based out of Silicon Valley, California. We also have an office in Bangalore. And what we do is essentially we bring computer vision, deep learning to the manufacturing world. Before we go further, let me ask you a simple question. Jousef, you see this iPhone. Mm-hmm. Now, while it was manufactured, take a wild guess at how many hands, human hands, and how many robotic hands touched it while it was being manufactured. So if you didn't know anything about it.
I would assume that way more robots touched it. But as I know that you founded the company Drishti, I think it's vice versa, right?
You're exact. Most people guess that it was largely built by robotic manufacturing. But the fact is, even at the cutting edge places, most of manufacturing is done by human beings. The answer, in fact, is 141 human hands. This is slightly stale information. It might have changed now, but until a year ago, it was 141 humans that touched that iPhone and 0 robots. And most of computer vision and artificial intelligence technology targeting the manufacturing looks at only the product, things, not humans. So we are basically not paying attention to the largest variability in the whole system. And this is what Drishti tries to fix. So we install video cameras at the factory floor and we look at the human being. We try to understand whether the productivity of the human being, how long it's taking each person to complete individual. We recognize actions that are being performed by the human being and time them and identify bottlenecks. That way we can, and also we identify quality loss. That is, a certain thing is being done in a wrong way. We would be able to tell. And we sometimes real-time warnings. Sometimes we create statistics based on what we have observed. Overall, we boost the quality and productivity of the factory floor using computer vision and deep learning technology. Mm-hmm. So this is what we are doing at Drishti right now. And I would like to point out that pretty much the entire deep learning that we deployed, hardly all of this is our own architecture or a popular architecture which has been adopted to fit our needs, which is to say there are outstanding patent applications for all of this, and this is in-house innovation that we are talking about. So that is Drishti. The largest portion of my working life was spent at Google. Mm-hmm. Where I worked for over a decade, 2004 through 2015, various departments, Google Research, Google Books, Google Photos. In fact, I built the newspaper search, Google Newspaper Search. And headed that product from its inception to several years. I also headed the Google News Archive for a while. and so forth. I have built several things inside Google Photos, the auto awesome product which actually improves your photographs behind the scene.
Mm-hmm.
Before that, until 2004, I was working for Adobe Systems at San Jose in what was known as their Advanced Technology Group. It's pretty much what used to be the R&D at that time. They didn't have a group called R&D. This was the R&D. And I have worked in various capacities there. I worked for Photoshop quite a bit. In fact, I worked on the transparency of Photoshop. Then PostScript, I worked a lot on making the images render faster there. So yeah.
So you did quite a lot, we can say. Briefly coming back to Drishti, if I have done my research correctly, Drishti is an Indian word, if I'm not mistaken, and it means something like see or detect, something like that. Can you maybe correct me if I'm wrong?
Yes. Drishti, actually, I think the best translation is vision. So there are multiple connotations in this word. So vision, we are a computer vision company. So Drishti is vision. Drishti is vision, just like the word vision in English has many meanings. All of those connotations exist in the Indian word too. Drishti also means vision in the sense far seeing, long-term vision. Yeah. I think that also applies here. And we are kind of like the eye of a friend that is watching the worker and kind of telling him, oh, this could have been done a little bit better, that this could have been done, this is not exactly, you took such long time. Remember, we are actually making the operator on the ground more efficient, because we are constantly, it's like a coach that stands next to your game and tells you about every move that you are making, or at least whenever there is a need to say something, the coach nudges you in the right direction. Mm-hmm. Is the way I think Drishti should be viewed. And thank you for bringing that up. That's a great, this name was invented by our CEO Prasad. And I think this is one of the first of many creative things he has done.
I see. So what I want to ask you, because you also mentioned that it's like an eye watching you from a friend. So I'm quite interested. So if you deploy that software or that framework, if we can say that, and people could feel that they are not private anymore because of the vision system, because if they take breaks that they should not take, that could mess up the statistics. Can you maybe explain in a crisp way how the system works and how you take measure against these kind of outliers? Like if you take unexpected breaks, you make fun with your friends at the working place. How is that taken into account? It's quite interesting to know, I think.
So essentially, the statistics, so scheduled breaks are taken out in the first place. So they're not going to mess up your statistics. Also, quite often, usually we do not produce individual statistics. What we present to as a statistics is the plant's statistics or the station's statistics, where individual human being is anonymized. So we lot of very strong, we don't collect any PII data, zero PII data. On top of it, we do present videos to the client, but we are actually, this is not fully baked in yet, but we are working on a head and face blurring technology, which would actually take you won't be able to recognize the worker unless you know the person very well and you can recognize the person from shoulder length or something. Normally, you won't be able to recognize the person in the videos that we present back to the management. And we do not collect a single PII information. So even Drishti doesn't know who that person is. Mm-hmm. Not to mention, so this is how we tell the management that this is the bottleneck station. I see. That doesn't mean this person is slowing it down. Mm-hmm. So So there is that difference.
Can you give us maybe a practical application to get a better understanding, or also that the audience understands it a bit better, where you have taken your system and made enormous improvements in terms of management and productivity? Would be quite interesting to know.
Yes. So Drishti has been deployed at multiple manufacturing stations all over USA, mostly in Michigan area, in Detroit. And there has been cases, remember, these are companies which are struggling to get, they consider 0.1% improvement in productivity as a great victory, because these processes have been honed for 100 years, perhaps 50 years. And there were cases where we have been able to identify process failures. There were 10% improvements in the tensor at one point. There is another very interesting case where where a particular client of ours was blamed by their upstream, like they are auto part manufacturers. They manufacture an auto part and send it to the main auto manufacturer. The auto manufacturer blamed them for actually a defective part. They were able to go into the history using Drishti software and to say this could have led to like tens of millions of dollars of business lost. What they were able to do, remember, we are not only analyzing the producing statistics, we also provide searchable video. In fact, you can say, let's say you're a brake manufacturer for a certain, for Toyota, let's say, and you can actually search says, show me the video where the brake pad was installed in the car. You can search at that level. Show me the video for brake pads being installed in the car on July 2019 or something. Using this technology, our client was able to go back and exactly show the video to their client and establish that this was not, the fault didn't happen at their end. So that is just one interesting example. But in general, our clients, like I said, in one case, there was a 10% improvement in productivity just by observing what is the bottleneck. So, such things. We are also deploying at some of the largest manufacturers in the world.
That's super interesting, Krish. Also, you have built an amazing system. Now, the question is, are there any competitors that operate on your level?
So there are competitors emerging now. When we entered the business, at that time, almost entirely the computer vision world was focusing at observing parts, observing objects. We observe humans. That was the chief distinction. At this point, though, certain competitors are emerging. So, Atology, Invisible.ai, and even Landing.ai comes to mind. Landing.ai is Andrew Ng's company. And people are beginning to recognize the importance of this. However, we have significant time advantage and also technology and patent advantages to we have a strong moat surrounding our company.
Get it. Now, the question that I have that just popped into my head, which might be a bit longer, but it's super interesting, I think. And a lot of people might know the AlphaGo from DeepMind and this famous Move 37 and that lead it as a human, but also the incredible moves from AlphaGo, of course. Now, the question is, humans usually think in a linear way. They cannot think like exponentially, and it's quite hard for them. And humans itself as a system are like non-linear. So that's this butterfly effect, that the one human causes something big. Is your system able to see that one mistake that happened, which you already mentioned a bit, like a long time ago, and then can see the forward propagation, so to speak, of that mistake? Because it's a highly nonlinear system, I assume, even in big factories. I assume that your system can detect this and also make suggestions that humans could not make. Would you say that?
To a small extent. Right now, we are focusing mostly on analyzing the video and identifying the mistake that happened exactly there. What you raise is a very interesting point. You are saying that this mistake which happened right there has a repercussion on many, like, you made a mistake in installing the brake pad of a car, which could ripple all the way till probably loss of life. Right now, we are not doing that, to be very exact. What we are doing is plainly analyzing the video and identifying what happened there. And if there was a problem we saw, we report that. That is all we do. Problem in terms of speed for completion, and problem in terms of not doing it in the right fashion or something. But that is all we do. And honestly, this is also hard enough.
Yeah.
Bringing hard enough to the point that very few people in the world, in fact, when we started, nobody in the world even attempted to do this. And even now, there is no known complete way to solve these problems, and we are focusing on that exactly at this point.
Now, from a programmer's perspective or engineer perspective, it would be quite interesting to know, if you can explain it, of course, how does the system detect the human? How does it work on a level that it's easy to understand?
Yes. So what we essentially do is we don't exactly observe the human only. In order to understand, this is one of the distinguishing factors of Drishti. We actually look at the entire scene, which includes the human action. We actually don't look at the face of the human being. Another reason of the PII. We actually look only at the work area, which is like the bench or table on which the person is working, which would include the hands, but not the face. But what we look at is a complex combination of hand motion, tools used, and the object on which, that is the target of the tool. We take all these three things into account and produce our. This is what deep learning allows us to do. So what we have is essentially, we actually, remember, this is a video, and generally detecting something from video is more complex in the sense compared to an image, because it has a third dimension. Image has only X and Y. Video also has a third dimension, time. So basically everything has a spatiotemporal aspect to it. Just to appreciate the difficulty, let's say I show you the frame of a door where the door is partially open and partially closed, like it's not aligned. Just by looking at that frame, would you be able to tell me whether the door is opening or is it closing? Can't, right? You have to look at full motion, right? Which is like saying, if you see me like this, do you know whether I'm trying to grab you or I'm trying to take my hand backwards? You can't look at it unless analyzing the temporal aspect of it. So what we have is a technology which is based on 3D convolution. It does a convolution in space and time. However, there are 3D convolution CNNs, that is convolution neural networks, that actually have been produced in the past. Our innovation is in making that convolution actually go through this space-time, the spatiotemporal volume. Imagine like we have small cuboids, which it's like a moving magnifying glass in space and time, which looks for the action that it has been taught to, and covers that, and that thing moves around in the whole spatiotemporal volume. That is roughly the technology we are talking about. We also are right now creating a system which tries to actually, with almost no labeling, we call it almost unsupervised. It's so one of the huge problems of deep learning today is that you have to collect volumes and volumes of training data and then curate it via humans. Now, this doesn't seem right. if you want to a human baby, you show the human baby like 3-4 dogs and it would recognize a dog, or 2 cars and it would know what a car is. Why do we have to send 200 to 500 calls to the deep learning network, to the neural network? This is some place where the entire world is shifting, and we also have an offering here towards what is known as either self-supervised, semi-supervised, and what we are developing right now, it's working partially, is an approach which essentially works with minimal supervision. We called it, it's a form of variational autoencoder, and we call it anchored variational autoencoder because we have a special twist to it. We put a little bit of training data, and it actually tries to create a space where what we like, what we want to know, and what we don't want to know, they're kind of separated in a lower dimensional space. That is these things are hard to explain in 3 sentences, but basically that is what autoencoders do. They create a space where things are separated. By the way, that brings me to one thing, that deep learning is essentially, a lot of it is geometry. If you don't understand the core geometry, then you are not doing it the right way, which I wanted to talk a little bit about a book that I'm writing. It is called Math and Architectures of Deep Learning, published by Manning Publications of New York. And it is written with a specific philosophy. I want to bring out the underlying math and the geometry. Pretty much everything you do in this is geometry of high dimensional spaces. Unless you see the geometry inside your head, it is extremely difficult to, you may be able to take a model which somebody else has built and run. If that doesn't work, you don't know what to do. And also you have very little understanding of what's going on under the hood. And my thesis at this point is that deep learning is not like driving a car. It's not, working on deep learning is not like driving a car where you don't need to know almost anything about the car. You can just drive. It's more like driving a space shuttle, perhaps. It doesn't work seamlessly. I haven't been on a space shuttle, so I hope it runs seamlessly. But, it's a very complex beast out there. There is a huge amount of theory, which is mathematics. And like I said, a lot of it is geometrical. But at the same time, it's intensely practical, where you need great programming skills. So what I have tried to do in this book is bring the mathematics and the programming together. I explain the math, without which I believe you are not a good deep learning engineer. However, the program, the Python, NumPy, and PyTorch code is right next to the math with exact practical examples, and you kind of match them. You can run every program has been tested and it's out there in the internet. You can download the program, run it yourself, and make sure that the math and program are giving you the same result. So this is one of the gaps that I observe. Internet is full of how-to recipes and cookbooks.
That's what I wanted to say next, exactly. Because if I have a look at your PDF and what you actually work on, as you say, there are a lot of cookbooks out there, and it's a bit of diluting, right? Because you have a recipe and you apply that recipe, and once that recipe doesn't work, okay, what are you doing now? You're kind of lost.
And right now the system is in such a place where there is not a recipe which works universally. Pretty much, it's not a commodity thing at all right now. Every problem needs your own adaptation, or you're not going to solve it very neatly. I suspect a lot of the failures is rising from this. You just try to take a one-size-fit-all solution from somebody and try to use it. And No, for example, what works exactly in the manufacturing world is not going to be what works in generic object detection. And so you have to adapt your solutions. This adaptation cannot be done nicely until you understand what's going on there. You have that geometrical view, that mathematical view in your head. And yes, this is exactly what I'm trying to bring out in the book. And you have to know why you are using. There are, let's say, just take a simple example, PCA. What are principal components? What are they doing in the geometrical space? These are the things one needs to understand. Otherwise, if you applied that, PCA doesn't work in the nonlinear world. If your space is nonlinear, it's not going to work very well. If you have that geometry, it's going to be a lot more evident to you. This is one of the principal tenets of the book. I am going to constantly bring out the math and right next to it the mostly PyTorch, NumPy, and Python program to actually work on that and demonstrate the linking between the two.
Now, you as an expert, and I think it's very interesting for the audience, I ask some of my guests what they think. Now, there's always this debate, okay, Keras, TensorFlow, PyTorch. Why have you chosen PyTorch? What makes it so special? Because I think PyTorch is one of the leading, if not the most leading framework that exists. What do you think of this competition between TensorFlow, PyTorch, and so on?
My sympathies would always be with Google. I feel enormously grateful to Google because that's where I was made. My identity is completely linked with Google, and I started with TensorFlow. What is happening to TensorFlow right now is, in earlier days there was something called Cafe. In this world, things move very fast, and people may already be forgetting. In Cafe, what used to happen is the whole thing was kind of it was very hard to see. It didn't even feel like you were programming. And that is also to a certain extent true in TensorFlow. PyTorch actually almost seems like I'm back in the old programming world where you just write your code and it's just a lot cleaner. TensorFlow is becoming more and more complex and beginning to seem like the earlier versions were not like that, right? And Keras helped a lot. It takes us closer to PyTorch in some sense. However, TensorFlow these days seem like a loose combination of somewhat disjoint things. That is what PyTorch doesn't. It seems like a very coherent set of programming tools. Another, there are a few places where TensorFlow is still unbeatable. One of them is visualization of what's happening. Their summary writer is much better. If you want to, and we use, even in PyTorch, we use the TensorFlow visualization of how the training is progressing. We are getting kind of deeply technical now. When a deep learning neural network is being trained, it's good to observe how the loss is propagating. Is it going downwards? Or you want to know after. You don't want to wait for 3 days and come back and see the machine has bombed. You want to see the graph of how the loss is progressing and perhaps how did the results look in the middle. All this is still better in TensorFlow. However, people have written adapters so that you can use them, that little bit of TensorFlow from a PyTorch program, which is what we do. And TensorFlow is still better in creating a summary of a model, for example. If you want to know important details about your model, TensorFlow would produce a much better summary. But all that has been already adapted to PyTorch. PyTorch seems like a better option when I want to know the overall structure of the program. I could just write my old style Python code and be done with it. I don't feel like too much. I have to go out of my standard programming paradigm too much.
Mm-hmm.
You don't almost have to learn.
Yeah.
That is why, and while writing the book also, I feel it's much easier to show the one-to-one correspondences between what the theory was and what happened in the program. It's much more evident in PyTorch. TensorFlow seems like somewhat imposed from outside in cases. And I say Keras has a potential to be as good as PyTorch. So that is quite possible.
I see. That's good input. Very interesting, Krish. Quickly coming back before we close things up. So what Drishti is actually doing, if we can mention it that way, it's basically to defeat the robots, but make humans, so to speak, stronger.
Yes, we are making the human being more competitive with using artificial intelligence. It almost seems like a contradiction in terms. I don't know, but that is what we do. We are helping the humans defeat the robots, not other way around. We are not making the robot more powerful. We are making the human being more powerful.
That's a beautiful statement. But what do you say to now that robots emerge even more and are put in the factories? And can Drishti also be applied to robot manufacturing lines or assembly lines? I would say so.
It is possible. We haven't done so at all at this point. But we could observe robots, I suppose. But like I said, a lot of manufacturing, the complex things in manufacturing are still done by humans. So, something as intricate as working on a mobile phone or working on an electronic circuit, there are not too many robots that are good enough to do that sort of intricate things. As a result, we will continue to analyze a human being for quite some time is what I foresee.
Yeah, and that's what brings us back to the beginning where you said that this ratio between how many humans touch the phone versus the robot, then that makes absolutely sense that Drishti focuses on that in particular.
There is nothing inherent in the technology that stops us from observing the robots. But we can if necessary. So, but business is here in observing.
Yeah, makes absolute sense. Is there anything else apart from your great book, of course, which I already have, fortunately? And I'll put the link to your book, of course, as always, down in the description with a discount code so you can get Krish's book, which is amazing. Because I have it already. I saw what's inside. And I think I'm completely on your level, and I agree on that, even as a beginner, so to speak, in AI, that mathematics is quite important, and it should not be taken. It should be taken with a grain of salt if you hear people saying, math is not that important, just use this framework and this command and you're good to go. Because as Krish said, there are recipes out there which are quite useful, but once you have the recipe and have to apply it to another problem, you are kind of lost. And that's where Krish's book comes in, because it tackles this problem and helps you understand the mathematics a bit better. What do I say? Quite a lot better. And do you want to say anything else regarding the book or your company?
No, I wanted to say hi to all the deep learning practitioners and experts and everybody out there, and just this is the beginning of a revolution. We are actually closer to the beginning than the end, and I feel we are on an exciting journey, and let's all have fun together.
It's a great time to be alive.
Coronavirus notwithstanding, it's a great time to be alive. Alive is the key word.
Yeah. So if people want to find you or reach out to you, how can they do it the best way?
So I am on LinkedIn, so please reach out to me via LinkedIn. That is a great way. I pay a lot of attention, and I think that is it. I am also Facebook, etc. I'm there, but I look at that less regularly, and So LinkedIn is the best way to contact me professionally.
Perfect. I will put the link to your LinkedIn profile once I upload the video in the description. Awesome, Krish. It was an absolute pleasure hearing from such a big expert in the field, having done so much. And hopefully we'll have a second part maybe in the future to see what Drishti has accomplished. And I would be happy to have a second part. Thanks a ton, Krish.
Thanks a lot, Jousef.